Hello again, Einstein. In this tutorial, we want to review finding the greatest common factor of not just numerical values, but what if we have variables, or variables raised to an exponential power? How do you find the greatest common factor? Well, it turns out it's not too different than when we find out the prime factor method of finding greatest common factors. You recall, on that section, we found the prime factors of a given number, say 72, which was 2 cubed times 3 squared. And then we would find the common factors of all the prime factors. So 72 is 2 cubed times 3 squared. And if you recall, 48 is 2 to the 4th, 16 times 3, which is essentially 3 to the 1, even though you typically never write that. And the common factors are actually the lowest power of the same prime base. So in this case, in the 2's, we have a 4 exponent and a 3 exponent. The lowest is 2 to the 3rd. In the case of 3, we have common 3's, but we've got the power of 1 and the power of 2. The greatest common factor is just the lowest power, or 1. The result is 24, as we found last time. What happens if it's a variable? It actually works much the same way. For example, let's say our two numbers were x squared times y and x times y cubed. Well, in this case, the base figure is a variable rather than 2 or 3. It's x, and x is raised to the power of 1 or the power of 2. The lowest exponent between the two common factors x is 1. So we would take x to the 1, and the product of that with the other common factors, in this case y, which is y to the 1, and y cubed to the 3rd power. And the lowest of those is again 1. So our result would be y to the 1. So our greatest common factor would just be x, y for this. Let's take another look at a mix of numerical values and variables, just to make sure you understand. If, for example, I had 12 y squared z, and my other value was 8 y z cubed, how would I find the greatest common factor between those two numbers? We would simply combine our two approaches for the numerical values and for the variables. So for the numerical values, we know 12 is actually prime factors 2 times 2 is 4 times 3. And 8 is simply 2 times 2 times 2 again. And let's lay out the factors for the variables. Those are y squared z and y z cubed. Now, our common factors for the numbers will be 2 times 2. On the variable side, we've got y to the 1, effectively, and y squared. So y to the 1 will be the common factors. And likewise, we have z to the 1, effectively, times z, and z squared, which means z is going to be a common factor. And again, just like we did for the prime factor method, we want to take the product of all these factors to get the greatest common factor. So our greatest common factor should just be 2 times 2 times y times z, which is just going to be 4y z. So here we see an example where we can find the greatest common factor of a mixture of variables and exponents, and numbers for yz. Thank you again, Einstein. Have a great day.